Hello, everyone, and thank you for listening to this presentation. My name is Simona, Associate Professor at the University of Technology, Sydney, Australia, and I apologize for not being able to be with you today to present live this presentation. The work that you are going to hear about today is around the e-scooter driving behavior by using beam data. And actually, this is some insights that we have obtained from the city of Brisbane, Australia. It's among a case study work that we have done in order to be able to understand the e-scooter adoption and the challenges with that. This work has been done actually in collaboration with Dominic Chong, my student, Tuo, Khaled, and Luis Carlos, with whom I really thank for the valuable contributions and advice so far to improving the findings. Now, um, before going into the presentation, I would like to say a little bit of um, words about the Future Mobility Lab at the University of Technology, Sydney. We have been working on a number of research topics in the last um, 10 years, and these are ranging from machine learning for traffic disruptions, traffic simulation modeling, digital twins, up to public transport modeling. Road safety is a big topic in Australia because we aim to have at least 75% of all roads that have 3-star safety rating, electric vehicle adoption, control, and so on. So please do follow up because there are many other topics that we work on, not just the e-scooter adoption and modeling. Now, before doing that, there is a little bit of recognition to our work. So feel free to check our website, fmlab.org, to find out more about some awards that we have also received for the work. Now, for today's presentation, I'm going to give you a short introduction about the e-scooter topic. What were our objectives when we started this study, and how did we do it? Now, as you might know, e-scooters are gaining a lot of popularity. They are an eco-friendly alternative of transportation, especially in urban areas, in CBD areas. However, it's not easy to integrate them in our day-to-day life, given multiple challenges that appear both in space and time utilization, but also from a policy and safety perspective, there are still a lot of challenges that appear. As there's currently no legislation or safety protocols that can be adopted. So few states in Australia have actually forbidden e-scooters. Melbourne has accepted them, Brisbane as well. However, some of them are thinking of closing this scooter adoption. So there's definitely quite a debate around them. There's definitely a limited understanding in finding out what are the factors that affect the e-scooter adoption, why are they popular, where, and so on. So what we actually realize is that there's definitely urban infrastructure limitations when it comes to the e-scooter adoptions. And definitely if you don't have space to run these e-scooters like bike lanes or dedicated green spaces, then it becomes challenging to mix up e-scooter usage with regular traffic. There are safety concerns, as I said, a lot of accidents being reported to the emergency rooms. And of course, there's definitely not so equal distribution and access to the e-scooters based on the social class or based on the cost because they're also costly. So what did we wanted to actually find out with this study? Is really we wanted to know whether the e-scooter usage fluctuates throughout the week. Are there specific times of the day that people prefer to use them? What are the characteristics of a scooter trip? Like, for example, we wanted to know on average how much time do people like to travel on e-scooters? And basically, is there any correlation or influence between these features? Also, we wanted to know whether departures, arrival, or journey density are different in various areas, and why would that be? So our case study was actually done in the city of Brisbane, Australia. And the data we used is actually from Beam. Now, Beam is a company that was founded in 2018, and they offer this eco-friendly solutions, right? The e-scooters for short trips around Asia Pacific. They want to be carbon negative by 2025, which is great. And of course, they use also analytics to improve the rider experience and finding out where they need to recuperate some of the fleet that are being left over, maybe in remote areas, and then rebalance them across the city. This is another challenge that I will talk very soon. As I said, they're operating in Asia Pacific, Australia, Malaysia, South Korea, and so on. And I think they're planning to expand even more. The data format that we received from Beam, and this is actually with the collaboration of Ferdinand Balford from the Micromobility Research Partnership, which I would likely want to thank, is actually in the format of a city ID. And then basically we had the start of each scooter trip and the end of each scooter trip. And of course, a unique identifier for that particular trip. We also had a user ID so that we can actually find out whether a user comes back later to e-scooter utilization or they're just one off. And definitely also coordinates latitude and longitude, basically to know where this trips are coming and going to. However, as you can see, we do not have any track GPS point along the trips, and this was a challenge for us, and I'm going to chat to you about that in a second. So what did we do with all this data? So first we started preparing and processing the data. We started cleaning it, basically duplicates or missing data or erroneous data. And we wanted to apply a standardized data format in order to be able to do spatial analysis. After that was finished, we started looking at what we call the descriptive analysis. What is that? Basically, it's just like trends, patterns, dispersion, overall distribution of the data set. What are the characteristics, and understand kind of like the heartbeat of the e-scooter utilization in Brisbane. I also want to mention today I'm only presenting the Brisbane case. However, there are multiple other cities, Hobart and quite a few other Australian cities that we have analyzed. However, for the time being and the available allocated slot, I will only talk about the Brisbane today. We then went to do what we call a temporal analysis. Basically, is really looking at this utilization across days, across hours, across years, trying to understand preferred peak usage time or fluctuations across different periods and so on. Once we did all this kind of like time analysis and descriptive analytics, we actually went to do a spatial analysis. So what is that basically? It's trying to have a look in space and time in space, basically where these strips are located and how each zone correlates to another zone. Why would that be? Now, as I mentioned earlier, we did not have GPS track points for each trip. That would have been absolutely fantastic because we could have mapped and also identify preferred routes of travelers. By preferred routes, I mainly mean either it's like a bike path or either it's, like mixed traffic or either is like parks and recreation areas. But unfortunately, we did not have that. And this to us represents kind of like the missing point for any future studies that we would love to have. Now, anyway, given the absence of this data, we, however, calculated the Haversine method and applied the Haversine formula basically to get the distances between start and end points, giving the shape structure of our Earth. And this is how we actually got the e-scooter trip distribution across Brisbane. Once again, it's a very rough calculation, and we would have loved to do the map matching as well. We also calculated probability density functions of trips per kilometer square. And based on that, we went further and try to visualize all this data via either what we called choropleth maps in order to identify variation in density. We also did a density analysis at mesh block levels to see the trends. Also applying some binding strategies, basically to be able to take some mesh blocks, categorize them by different density brackets, calculate quantiles for each mesh, and so on. And I think the last point, given the limited data set that we had, we looked at the distribution of origin to destination matrices, which is basically looking at origin and destination interconnectivity in terms of demand. So the number of trips. So let's say, for example, you have a CBD area and you want to know from that CBD area, on average, how many trips are going to, let's say, a peripheral area. So we actually grouped all these start points, end points, in order to be able to match what we called OD pairs. So origin destination trip pairs into the city. We did this by time, and this allowed us to extract temporal OD matrices, but also we noticed quite an imbalance in the origin destination matrix analysis. Basically, some times of the day are actually more popular than others. This means that we had to see when this imbalance of origin distribution matrix occurs and trying to understand why. So this is it in terms of methodology, and let's have a look into those results and insights with regards to this data set. Now, when we started plotting out and looking at the total daily trips in Brisbane since the launch of this service somewhere around mid 2021, we realized that really it's a very spontaneous kind of like service adoption. It was hard to extract any seasonality. A lot of people, they were using it probably on and off, maybe for curiosity, maybe to explore specific locations, but not really like as a kind of like integration into their daily activities. So there was definitely interest, right? However, still the patterns were to be refined. So I have to mention we got data until last year, 2023. It will be nice to see how in 2024 this trend would look like. When we actually started grouping this by day of the week, from Monday to Sunday, we realized that definitely there's a strong activity. And for each day, majority of the trips were above 300,000. Fridays and Saturdays are reaching the peak usage in terms of e-scooter activity. For some reason, maybe due to some weekend outings, maybe some social events, etc. So looking at that, there's definitely a trend which is influenced by patterns regards to the working week. When you look at the distribution of trips per hour of the day, so this is actually what you see here, it's a 24-hour distribution spread of the total number of trips, we realize that definitely there's a strong interest for using the e-scooters in the afternoon. So as you can see, after 1 p.m., the e-scooter utilization increases, and it actually it peaks around between 4 and 5 p.m. That's the time when a lot of people are getting off work and probably heading back home or for any other social activities. And if you actually look at this trend curve as well, you can see that there's a small peak at 8 a.m. for weekdays, but definitely a large peak for afternoon. Weekend trips are much lower. This is interesting, right? So you would expect like e-scooters being used maybe for leisure during weekends. Yes, they are, but not as much, right? So the trend curves as well during the weekends starts to increase a lot after 10 a.m. and reaches its peak around the 3 p.m. So this reflects like the preference for people for this type of e-scooter and micromobility mode. When we're looking at trip duration, we realize that overall trips last about 10 minutes, especially during weekdays, a little bit longer during the weekends, 12 minutes, and also in the evening. However, morning trips are in general below 10 minutes. It's just reflecting the morning rush style. When we look at the distribution and the travel histogram, we realize that definitely the data tells us there's also a sharp peak at 0 kilometer, meaning that I think these are errors. Either people that wanted to use the service, they couldn't, they maybe got blocked because of the payment methods, or maybe they were not used to the service and they abandoned using the service, right? However, majority of them, the common distance is below 1 kilometers. And actually this distances diminishes slowly after 6 kilometers. So I think that they are used for short trips. As you can see, the average distance is 0.88 kilometers, definitely longer for weekdays, shorter on weekends, and so on. However, this tells us that yes, it's just a mode that is starting to be adopted for short distances. We also want to make a representation that our calculation method is based on the Haverside method, and this might be very rough. I think these numbers might look a little bit different if we would have had the GPS points. Now, because of that, we can actually start like cluster and classify the activities for different needs. So, for example, if we separate these trips for a residential kind of like access, there's definitely majority of the trips, 1.35 million departures versus 1.39 arrival points. So definitely people are using them for residential, going to work and going back home. Also, they're using it for commercial activities, which means that going for shopping or things like that. There's also other categories like going to parks or education or medical, etc., but these are much lower, much in intensity. When we looked at the mesh block distribution, we realized also some differences between departures and arrivals. So I know this might seem a little bit similar. So this mesh block is actually using the definition by blocks that we can find. So the spatial distribution of block kind of like spread out. So definitely a lot of departures are happening from Brisbane CBD. However, when you look at the arrivals mesh plot distribution, you do realize there are some remote areas, like suburb areas, that start to appear, which means that people are departing from CBD, mostly probably after work, and using these e-scooters to go back home in the suburbs. And this is quite interesting to find out. For each of those mesh blocks that you see, we can actually calculate statistics and numbers. And when you start ranking these blocks, you can actually identify the top 10 that are the most popular. And this one, the blue ones that I have here, by departure or arrivals, gives us exactly the suburbs where the activity is the most intense. So this is very useful for city planners when they want to really make changes in those suburbs in terms of accessibility or other facility, like installing dedicating parking slots, etc., etc. So this is something that we can do by doing the mesh block analysis. Further on, by doing that mesh block, choropleth representation, we can actually start and calculate what we call heat maps. So this is actually a morning heat map of Brisbane between 6 and 11 a.m. Divided by departure and arrivals. And you can also compare it with afternoon heat map. So if you look at these two, you might say that they are very similar with the naked eye. However, have a look when you hover between them. So definitely in the evening, there are more. If you look on the right side, you realize that there are more suburbs that start to appear in terms of arrival. So again, talking about that outside suburban arrivals from users going back home after a long day of work. This is the same thing. I just wanted to show you like a different area. This is Brighton, a different kind of mini city where you can see, for example, the choropleth utilization a lot along the shoreline. And basically, if you plot that, and you can definitely see the difference between morning and evenings, and people taking the e-scooters in the evenings to actually go back home. So we confirm that this is the trend. This means that a lot of e-scooters will remain in the suburbs in the evening. So the company actually needs to organize separate like pickups and recollection and reallocation to the CBD for next day. That's not very easy and challenging, of course. If you have to look at the percentages of journeys that stayed or left those mesh blocks, it all depends on the section, the slicing method that you use. So we use mesh block given that is the finest, but we also did SA1, SA2, SA3, like different mesh block calculations at different high level. So this means if you look just at the mesh block, like very granular detail, you realize that, of course, a lot of the journeys leave their original starting point. However, of course, if you choose to do the analysis at SA3 level, which means like larger areas, only 32% leave that area. So it's pretty normal. I think that councils and they need to look at what areas they can actually make adjustments based on the councils and based on their desire to be able to influence utilization of this modes of transportation. The final thing I'm actually going to talk about is the regard origin to destination matrix. So actually, we took all these mesh blocks for city of Brisbane. So maybe it's very little. You can't see their IDs here, but that's not the point. So when you actually start building what we call origin and destination matrix, you just list all the areas that you have, and you start kind of like calculating the total number of trips between each area, right? So there's definitely an origin destination matrix with a diagonal that indicates trips departing into the same area and staying in the same area. These are highlighted actually using this color scheme. And I just wanted to let you know that definitely there is some interconnectivity between specific areas into the city, as you can see here. It's not very easy to identify them, right? A lot of them, as you can see, the yellow spaces are actually zero. So there are no trips between specific areas and suburbs, and this actually makes it challenging for future calculation or statistics. We also wanted to see the imbalance metrics. So we subtracted actually the afternoon OD matrix, which we have seen that is actually much bigger from the morning OD matrix. And we wanted to see actually this imbalance, like how many people prefer to be more on the afternoon and from what areas. So if you would actually, this asymmetry in e-scooter utilization, you can see them by calculating this OD matrix imbalance. So this is it, how it looks like. So the same thing, all calculated between all suburbs that we have, and the gray kind of like representation gives us like the a heat map of the areas that have the biggest imbalance. So you can definitely see there are 3 clusters in the entire network which have like the clear imbalance between trips, and this can be identified, right? We can offer this analysis to councils to know exactly where that happens, and of course to BIM. We also took one step further, and we represented this as more as OD trips and like how should I say, vectorized kind of like interconnectivity between these suburbs. There's definitely a red mesh plot happening here. And you can't really tell much from it, right? So by looking at you, you'll be like, oh, wow, that is very interesting. So definitely some areas are highly interconnected, but very, very hard to read. So however, this data is very valuable because you can rank it, you can filter it, you can separate it in those 3 clusters. This is just a small in the right, a small representation of the top 50 data points for Brisbane, which gives us the highest imbalance between specific OD trips. And definitely you can see that Brisbane CBD on the right side of the river is the one that is experiencing the biggest number of imbalanced trip, mostly in the afternoon. A lot of activity is happening here, and people are preferring to take the scooters from this area to go into the suburbs. So this is it with all this kind of like insights, and you And definitely for us was lessons learned in order to understand how e-scooters are being used for what type of purposes and from what area to what area. So I think this really lays off the baseline between building future models. So we can now employ future machine learning models to start building correlation between specific features that influence e-scooter adoptions, or to rank those features that affect or influence positively the adoption of e-scooters. There's quite a lot of things that can be done from here, and we are very interested to further explore this topic. There are some future research direction. We want to really look like what would be the impact of weather when it rains. Do people still use them? Probably not. Weather infrastructure plays a huge important, like for a role. For example, if people do not have any bike lanes or parks or any other alleys where they can safely use the e-scooters, can actually this influence their decisions to not take them, etc. So I think this is for us just the beginning. We also want to couple this with other modes. So for example, how many people would take the e-scooters from the suburbs and drop them at the nearest tram or the nearest metro station, etc. How fantastic would that be to see that multimodal interconnectivity? But for doing this, we need data. So thank you so much. Please get in touch. Write me any questions at this email address. Check us out on our website. And I really hope to get in touch with some of you, even if remotely. Thank you.